This is the screencast for section 3.5, example 1. We are going to revisit differentiation rules. We've got to remember all these rules as we go through the course because differentiation or taking a derivative is going to pop up all the time. So, looking at part A, y equals x squared times the sine of x, find the derivatives. Well, this has multiplication in it, so I'm going to use the product rule, and then within the product rule, I'm going to use different rules. So here we go. My u, so to speak, is x squared. My v is sine of x. So y prime is going to be, let's take the derivative of the first part, so 2x, and then leave sine of x alone. And then plus, now leave x squared alone, and the derivative of sine of x is cosine of x. So I am done. Part B, there is division here, so we are going to have to use the quotient rule, but I understand the quotient rule a lot better when I write it out vertically, so that's what I did here. So now I'm going to take the denominator and leave it alone. That's what I'll see first in the numerator. And now take the derivative of the numerator. Now, if you haven't taken a second and explored this page of your notes, you should do that, because it takes you through the derivative of your 4 trig functions and revisits a limit that is very important as well as a new limit that is very important, and graphically and numerically why that works out. So now the derivative of cosine, the derivative of that numerator, is negative sine of x minus, now we'll do the opposite, we'll take the derivative of the denominator. So the derivative of 1 is 0. The derivative of negative sine of x is negative cosine of x, and then times leave cosine alone. And then all over the denominator, original denominator, squared. So we'll simplify some things in the numerator. And I see a familiar trig identity. Sine squared of x plus cosine squared of x is 1. So the negative sine of x plus 1 and 1 of the 1 minus sine of x is in the denominator cancel. And I get 1 over 1 minus sine of x. The now try problem number 5 says use your grapher, find dy dx, and then use your grapher to support your analysis if you're unsure of your answer. And of course we're always unsure, we want to be absolutely positive, so we will use our grapher. Alright, number 5, y prime equals the derivative of 4, a constant, is 0. Don't even need to write that, but I'm going to for notes purposes. And then I have the derivative of something that looks pretty familiar from example 1. Since we have already taken this derivative, I'm just going to go back and refer to what its derivative was. Derivative of x squared sine of x is 2x sine of x plus x squared cosine of x. So now I can check my answer by putting in y1, the original problem, y2, what I think the derivative is, and then in bold in y3, tell the calculator to take the derivative of y1 with respect to x, and I can see that with the right window, the calculator's derivative is graphing right over mine.